Hello, today we're going to be looking at areas, and a lot of this you've seen before, but maybe you haven't really thought about where the formula comes from and such. So hopefully, um, this clears those things up. The first thing we need to know about area is that it's the number of square units needed to cover a surface, whether it's the square inches, square miles, square centimeters, square, or just square units. It's how many square units it takes to cover that surface. So if I look at this, if I want to find how many squares are in it, I could just count how many squares are here, and that's going to be the total area. So it looks like I have 6 up there, and 3 by 5, that's 15. So I have 21 square centimeters, because each of these is 1 by 1. So this just builds the idea of what a square centimeter is. It's a square, that's 1 centimeter by 1 centimeter by 1 centimeter. We could do the same thing here. We could say this is 9. This one's a little bit tricky because we have half. We can piece them together, or we can see that there's really 6 that are just cut in half, so that would be 3. And so if you add them together, it's 12, and this is representing a foot, so that's 12 square feet. Now, one interesting thing about square feet and square inches is it doesn't have a linear equivalence. So what that means is if I have 1 foot by 1 foot, that doesn't mean that this is going to be 12 square inches, because really this is 12 inches by 12 inches. So if I want to find how many square inches that is, that's 144 square inches. Similarly, if I have 1 centimeter by 1 centimeter, well, hopefully a lot of you know that there's 10 millimeters in every 1 centimeter. So there's 100 square millimeters in 1 square centimeters. And if you think about it, if I divide this into 10 lines that way and 10 lines this way, there'd be 100 little squares in there. All right, area of a rectangle. Area equals base times height. Why is it that way? Well, that's what multiplication is. You take however many this way, multiply it by how many height, you have your area. So if I want to find the area of this one, well, we have this distance, which is 1 squared plus 3 squared. That's what, square root of 10. With this one, what do we go over? We go over 6 and up 2. So that's 6 squared plus 2 squared is equal to c squared. 36 plus 4, that's the square root of 40. All right, awesome, great. So now if we want to find this area, we take the square root of 10, oops, times the square root of 40, and that's going to be the square root of 400. And that's really nice because it comes out to a nice number of 20. And we should, whenever there's not units, we put u, just whatever square units that is, that's how many would fit inside of that box. All right, area of a parallelogram. Now, I can take a parallelogram like this and move it into a rectangle. So I know the area of a rectangle is base times height, so I just do the same thing here. Area equals base times height. But the thing to think about uh, is this 5 doesn't have anything to do with the formula, because the base is going to be the perpendicular base, because that's what we need when we make a rectangle. So it's 7 times 4, which is 28 square centimeters. There we are, area equals base times height. And the height as of a parallelogram is perpendicular to the base. All right. Now if we do this, you just multiply them 17 times 4. I think you guys can do that. Now here, some people get tripped up on a problem like this. We have 14, but we don't have the perpendicular. So we have to think about this being the base as well. So 9 times 12, which is 108. So this answer is 108 square feet. Now we have a parallelogram that's at 4, 7, 2, 1, 8, 1, and 10, 7. So now we have to think about what kinds of information do we need? Well, we need to figure out this distance from 2 to 8 is 6. That was easy. Now we need to find this distance. That's from 1 to 7. That's 6. So the area is 36 square units. It's supposed to be a U. All right, now I think you guys can go from there. How do we find the area of a triangle? Well, the area of a triangle, what we do is we just, if I take this and flip it over, that makes a parallelogram. And the area of a parallelogram is base times height. Now we just only want half of it, so it's divided by 2. So every single triangle we can manipulate to make it so it's half of a parallelogram. So that's why we have base times height divided by 2. Some people put 1/2 base times height. Whatever way you like it, go ahead and use that formula for area of a triangle. Um, Now again, in this one, the base and the height always have to be perpendicular. So in this case, the only two perpendiculars we have are 8 and 5. So that's 40 divided by 2. So that's 20 square centimeters. How do we find the area of a trapezoid? There are two good ways that I can explain where this formula comes from. One of them is to make a rectangle again. If I make a rectangle here, this piece can go up there, this piece can go up there. Now we just need to find that distance in the middle. That distance in the middle is called the mid-segment of a trapezoid, which is just the middle of those numbers. So 4 plus 6 divided by 2, and then we multiply it by the height of that trapezoid times 3. So 10 divided by 2 is 5 times 3, that's 15 square units. Another way is to take it and flip it over and make a parallelogram. So now if we have this parallelogram, it's base 1 plus base 2, 4 plus 6. And then we're going to take that times the height. And then once we have all that, divide by 2. Same thing. You get the same answer. Just two different ways of looking at it. So the formula for a trapezoid is base 1 plus base 2 divided by 2 times height. Or some people do base 1 plus base 2 times height divided by 2. It's all the same stuff. Whichever one feels better to you, go for it. So if I wanted to find the area here, we have one base, which this distance is going to be 5. This base, the distance is 7. So we have 5 plus 7 divided by 2. It's obviously 6. And so we take 6 times whatever the perpendicular distance between the two bases is. And what's that? 2 plus 4. It's also 6. So that's 36 square units. The area of a kite. There's a couple different ways of doing this one as well. What I like to do is take this piece and put it there, take this piece and put it there, and now you have a rectangle where this length is your diagonal 2. That's that whole distance up here. The distance here is half of your diagonal 1, which is going to be the same thing here. So the area of a triangle, we just take half of diagonal 1 and then multiply it by diagonal 2, and we have a nice little formula for the area of a kite. Now keep in mind that the diagonal is the whole distance. So if I go from here to here, that's going to be 6. And if I go from here to here, that distance is from 4 to negative 5, that's 9. So 6 times 9 divided by 2, 54 divided by 2, gets us to 27 square units. Now we have the area of a rhombus. The area of the rhombus is the same thing as the kite because we can do the same thing where we make a rectangle, bring this down there, that down there. Or it's also a parallelogram, so we can use area equals base times height. So it just depends on what information we're given about a rhombus in order to figure out what formula works. But that, two different formulas work for it. Now, how do we find the area of a circle? This one, most people know area equals pi r squared, but they don't necessarily think about where it actually comes from. So we're going to break it down here for you. So if I have a circle and I cut it up into a bunch of parts, the more parts you put it in, the better it works, but that'll make more sense later. So we take it, and now if I take this and I lay them out flat, hopefully you can see this is starting to look like a parallelogram. Now, if I color the top half light purple and the bottom half dark purple, you can see that um, that it's half and half here. And now this distance is, we know the distance around the whole circle is, circumference is pi times diameter. So if I want half of it, that's pi times radius. So I also know that this distance here is a radius. So I take pi times radius times radius. So that's how we get pi times r squared. So pi times r, pi r squared. That's how it is. Now from here, I think you should be able to do the rest of the work. Good luck.